Welcome to Algebra 2. This is still Unit 2, graphing functions, and this is in Section 3, rate of change or slope. Well, slope, we all know, represents how steep a line is. And slope, another way how we all remember it is rise over run. We use the lowercase letter m to represent slope. And if we have 2 points, x1, y1, and x2, y2, our formula to find slope is y2 minus y1 over x2 minus x1. This is referring to the change of y over the change of x. Some of you will start seeing change of is the delta symbol. It's a triangle, means change of. So this is also another way how you can represent slope, saying the change of y over the change of x. Most of us, we will be sticking with that formula throughout. If you understand this, go ahead and use it. So we want to find the slope of the line that passes through each pair of points expressed as a fraction. Doesn't matter which one you view as x1, y1, and x2, y2, you just have to make sure you do the right one. Some of you will find the need to label. Once again, most of you probably won't. Slope is equal to y2 is negative 2 minus y1 is 4 over x2 is 1 minus x1 is negative 1. Negative 2 minus 4 is negative 6. 1 minus negative 1 is 2. Negative 6 over 2 is negative 3 over 1. We're going to actually write that, express this as a fraction. So this is the slope. We do know that negative 3 would also be the same exact thing as negative 3 over 1. But most of us will be able to graph this easier if we have it written like that. Second up, 0.82 and 8, negative 1. So make the first one our x1, y1, our second one x2, y2. Slope y2 minus y1, so negative 1 minus 2, over x2 minus x1, 8 minus 8. So we have negative 3 over 0. Uh-oh. Oh no. We're dividing by 0. Can we do that? That's not possible. So this is undefined. We can never divide by 0. Undefined means that we have a vertical line. All right, and if we were to plot these 2 points on a grid over 8 up 2, over 8 down 1, we would also see that those 2 lines would plot and form a vertical line. Next up, we got the 0.54, negative 3,4. So we'll call this first one our x1, y1, and the second one our x2, y2. So y2 minus y1, 4 minus 4, over x2, negative 3, minus x1 is 5. So this becomes 0 over negative 8. 0 over anything is 0. So this slope is 0. A slope of 0 is a horizontal line. And this should make sense because if you have 0 steepness, you would think that this is a very flat line. So 0 steepness, flat line, it's a horizontal line. And one last example here with slope, like this. The 0.57 will be our x1, y1. The 0.3, negative 2 will be our x2, y2. So slope would be negative 2 minus 7, y2 minus y1, over x2 minus x1, 3 minus 5. Negative 2 minus 7 is negative 9. 3 minus 5 is negative 2. Both have negative signs, so negative over negative will give us a positive, and this is 9/2. You may not write slope as 4.5. That is not okay. Slope must be expressed as an improper fraction. All right, otherwise it will be very difficult for us to actually graph these. All right. Next example, we want to find the rate of change for each equation. So we want to find the slope. So the way how we can do this is we can actually think of finding our x-intercept and our y-intercept. Okay, so I'm going to find the x-intercept and the y-intercept. Remember, x-intercept is when y is 0, y-intercept is when x is 0. So our x-intercept here, if y is 0, our x-intercept is negative 4. So we just have x equals negative 4. Our y-intercept, so if our x is 0, we have 4y equals negative 4, or y is equal to negative 1. Now, in order to find this rate of change or the slope, we're going to plot those points. So x-intercept of negative 4, that'd be right there. Y-intercept of negative 1. Rate of change is rise over run, so we can count. So starting at one of the points, here we had to rise 1. And then we had to go over to the left, 1, 2, 3, 4. Since we were going to the left, it makes it negative 4. So here, our rate of change, or our slope, is negative 1/4. Okay, second example, same idea. We're going to find the x-intercept, y-intercept, plot it, and then figure out what the rate of change is. So x-intercept, your y is 0. So here, if our y is 0, we're left with 2x equals 10, divide by 2. So our x-intercept would have to be 5. Okay? To find our y-intercept, we know that our y-intercept is x equals 0. So if x is 0, 2x is not there. So we have 5y equals 10. Divide both sides by 5. So y is 2, so our y-intercept is 2. All right, so we can sketch a little graph to see what's happening here. So here I'll sketch a graph. You may, of course, also use graph paper for this, but we don't have to be terribly precise. So our x-intercept is at 5, 1, 2, 3, 4, 5, put your point. Y-intercept is at 2, 1, 2, put your point. And now we want to find the rate of change. So start at one of the points. I have to go up 1, 2. So I went up 2, I rose 2. And then I'm going over 1, 2, 3, 4, 5. And I was going to the left, so I'm going to make it negative. So here the rate of change would be negative 2/5. All right. Now we want to find the value of r so that the line passing through each pair of points has the given slope. So to do this, we just need to think of what our slope formula is. Our slope formula is y2 minus y1 over x2 minus x1. We're just going to plug in everything, and we'll be able to solve for our missing variable. So 3, 2, I will make my x1 and my y1. 8r, I'll make my x2, y2. And then here, look, I have m is 2. So m equals, so 2 equals y2 minus y1, r minus 2, over x2, 8, minus x1, 3. Simplify. 2 is equal to r minus 2 over 8 minus 3 is 5. I want to get rid of that denominator here, so I'm going to times both sides of this equation by 5. Those 5's cancel. 5 times 2 is 10, is equal to r minus 2. Now solving for r, I add 2 to both sides, so my r in this case is 12. And then, of course, you could plug that 12 back in and double check that that actually does work. All right, next example. Same idea. R11 is our first point, so we'll make that x1, y1. 24, negative 9 is our second, so we'll make that x2, y2. And then our slope is negative 5/8. So m, negative 5/8 is equal to y2 minus y1, so negative 9 minus 11, over x2, 24, minus x1, r. Okay. Now, in this case, we have 24 minus r in the denominator, and we can't just simplify that, so we have to get that out of the denominator. So we can do this by multiplying both sides of the equation by 24 minus r. So this would give us 24 minus r times a negative 5/8 on the left-hand side is equal to negative 9 minus 11. Well, we know negative 9 minus 11 is really a negative 20. This negative 5/8 now we will distribute throughout. So remember, when you're dealing with fractions, 24 divided by 8 is 3, times by 5 is negative 15. Negative 5/8 times the negative r is a positive 5/8 r, and then is equal to negative 20. So now we'll add the 15 because we want to solve for r. So we have 5/8 r is equal to a negative 5. All right, to get rid of 5/8, we can times by the reciprocal of 8/5. So 5/8 and 8/5 cancel, so we're left with r equals, the 5 in the numerator and denominator cancel, so we're just left with a negative 8. So in this case, r is equal to our negative 8.